So in this question, we are given that there are three charges, minus q, plus q, plus q. They are separated by distance d and d as shown in the figure. And we have to find out electric field at this point P, whose distance is A. It is given that A is much larger than D, and it is also given that 2qd is equal to P. We have to find out electric field at point P. So there are two methods of finding this electric field. One is superposition of electric field, that is find out electric field at P due to minus q, find electric field due to plus q, and find electric field due to this plus q. So by finding the electric field due to each individual charge at this point and doing vector addition, we will get the resultant field. But we can use one formula of dipole, and that will make the calculation much simpler. So what we are going to do is, this minus q and this plus q, these two charges can be considered as a dipole moment, and the electric field due to this minus q and plus q will be in this direction. As you know that electric field due to a dipole on its equatorial line. For this dipole, this line is an equatorial line. And electric field on the equatorial line is opposite to the direction of dipole moment. So this is, let us say, E1. And we know the value of E1. The formula of the electric field on the equatorial line is Kp by r cube. Here this r is a, so it will become Kp by a cube, and P is already Q into 2D. So we will put this value here, or we can use this value there. Now the other charge is plus Q. So due to plus Q, the electric field at this point will be straight in this direction. Let us call this electric field E2. The value of E2, as you know, is KQ by A square. So the resultant field is equal to root E1 square plus E2 square. This will be your answer. The values of E1 and E2 can be substituted from these two.